Hello everyone, we're doing definite integrals again. This is a re-recording because I made this video a couple of years ago and brought shame upon my family by making a fairly silly mistake in it. So if you want, you can probably find the old version somewhere on the net and watch me embarrass myself. Let's see if I can get it a little better this time. So there's going to be functions here. We're supposed to find the area bounded by these two curves and also by the y-axis. More about that in a moment, but let's get these drawn. Y equals minus x squared plus 4 is a parabola, which opens down and has its y-intercept at 4. So 1, 2, 3, 4. If you factor this, you'll get 2 minus x and 2 plus x, so the x-intercepts are at negative 2 and 2. That gives us a good idea of the proportions. And so it is parabolic and is shaped something like that. Y equals negative 2x is a straight line, which passes through the origin. Its slope is negative 2, so it goes down 2 over 1. So it looks something like this. And if we were just looking for area bounded by these two curves, we'd have this nice region here, which lies inside both of those curves. But that's not what they want. There's a little more here. They say any area bounded between the curves and the y-axis as a right-hand boundary, i.e. we only want the areas left of or touching the y-axis. So in addition to the two curves I just drew, they're also saying the y-axis is a bound, and we want the stuff that's inside all three of those regions. Or sorry, all three of those curves. So this, only up to the y-axis and no further, is the region they actually want. All right, so if we set up an integral for that, these rectangles of area that we're trying to define here will have a width of dx, as usual, and their heights will be how high are they at the top minus how high are they at the bottom. The tops of these rectangles are always negative x squared plus 4. That's their upper bound minus, and their lower bound is the straight line, so negative 2x. Now, too many brackets, too many double negatives. Let's clean that up right away. We get negative x squared here. Negative negative 2x is plus 2x. And then we have a plus 4. That's better. It's not an integral without the dx. And for boundaries, in the x direction, we're stopping at x equals 0. That's the y-axis. That's our right bound or our upper bound. And the left bound is this corner here where the two curves meet, which they have not given us. Better find it. This point would be where negative x squared plus 4 intersects negative 2x, meaning where is it equal to negative 2x? If we take everything to the right side to get a positive leading coefficient, we get positive x squared minus 2x minus 4 equals 0. The first thing one tries to do with this is factor it, but there aren't any integers that multiply to 4 and add up to negative 2, so that's hopeless. So out comes the quadratic formula. Our x's would be minus b plus or minus root. B squared is 4. Minus 4 times 1 times negative 4 is negative 16. So we have 4 minus negative 16 all over 2a is just 2. 2 plus or minus root. 4 minus negative 16 is 20 all over 2. And we could simplify that to 1 plus or minus root 5. Two values. 1 plus root 5 would be the positive intersection over here, which doesn't interest us. It's nowhere near the region we want. And 1 minus root 5 would be our left boundary here. 1 minus root 5. Now, you can do that with the exact value, if you like, Or you can just say 1 minus root 5 is negative 1.24 and solve it that way. Um, I don't know. I'll probably just do the decimal here and posit that we could calculate the exact version if we really had to, if lives depended on it. But either way, that's your left boundary. The right boundary is 0, and we're all set. Now, we haven't actually done the integral yet. So, as in the antiderivative, so let's make that happen. Power increases by 1, divide by the new power. Power increases by 1, divide by the new power, and we just get 1x squared. And for the 4, power increases by 1, so x to the 1 divided by the new power. And we really don't need a plus c in a definite integral because it's going to cancel anyway. So we're doing this from 0, or sorry, from negative 1.24 up to 0, I should say. And now we take these numbers and plug them in to the antiderivative. So lots of careful arithmetic here. Minus 1/3 0 cubed plus 1 times 0 squared. Am I spending too much time on plugging in zeros? Yes, I am. We know what's going to happen there. Minus, and now the spicy part, minus 1/3 negative 1.24 cubed plus negative 1.24 squared plus, sorry, I'm pushing the limits of legibility here. It's a lot to fit in. If it makes you feel any better, my hand's cramping from writing this small. Okay, so all this comes out to 0 minus, and now a lot of calculator stuff. 1.24, it's negative, to the 3rd power times negative 1/3. I get 0.6355. Hopefully that's enough. They didn't say anything about what precision they expect here, so hopefully 4 decimal places will do it. And then we have $1.24 squared is 1.5376. That has to be positive because we squared it. And then we get 4 times negative 1.24 is minus 496. 0 minus, we're still working in here, 0.6355 plus 1.5376 minus 4.96 negative 2.7869. Double negatives cancel out, and we get 2.7869 for the area. Areas should come out positive if you've configured everything right, so I was kind of sweating when I saw this negative here, and then I remembered, wait, there's another negative out front. It's going to be okay. So that should be the area bounded by those two curves. And we could run this again with 1 minus root 5 if you wanted to get a deadly accurate answer. If you want to do that and check your answer with your instructor, you go ahead. I choose life.